Okay, let's take a look at this problem. Now I'm going to use my my custom distribution calculator to help with this problem. The probability histogram to the right represents the number of live births by mothers 44 to 47 years old who have a live birth in 2012. So we got probabilities, we got a distribution. Let's look at this. The probability that a randomly selected 44 to 47-year-old mother who had a live birth had her fourth live birth. Okay, so the fourth is, that means we just have to look at the histogram and read. On the bar 4, we have 0.113. There's no need to do, we don't need any special calculator to do this. What's a probability, fourth or fifth? Okay, so rather than having to actually do any calculation, which is very minor, but still, let's go over to the probability calculator, and I'll show you how to use some features that I've built in. So, first of all, we've got, this is the custom distribution calculator. I'm going to build this frequency distribution, or this probability distribution into here. Now, first off, you notice that we've got 8 possible values, 1 through 8. I'm going to put an 8 for the possible values, and I'm going to start with the value 1, and I'm going to click auto increment. That's nice. We don't have to type in all those numbers. It just starts with 1, and whatever value was in this first cell here, it's going to just start counting up from there. The probabilities, I'm going to start typing in 0.233, 0.286, 0.169, 0.113, 0.106, 0.022, 0.026, and the last one is calculated for me so that it adds up to 1. Now let's get back to the problem. It was asked, what's the probability that the person who had the mother had a live birth, it's a fourth or fifth live birth. Let's use this calculator to get the number for me. I know it's such a silly calculation to do with a calculator. I can actually add the numbers, but just for argument's sake, I'll show you how it works. So I'm wondering the probability that I'm getting the fourth, anywhere from the fourth to the fifth. Well, okay, fourth. So notice when I clicked on here, I get cumulative probabilities. That's just a nice feature that you can see those calculated for you. But what's the probability? It's from the fourth to the fifth. So 4 to 5, okay. I've got the area, the probability is down here, 0.219. Notice I've got some other numbers calculated. Expected value, that's the expected value of the whole probability distribution. We'll use that later. But let's type this in. This probability was 0.219. Check the answer. Okay. What's the probability that the randomly selected 44 to 47-year-old who had a live birth had her sixth or more live birth? Okay, let's use this. Let's go the probability that the x is greater than or equal to 6. And calculate. I click recalculate down here, and I got 0.93. That's adding up the last 3 numbers in the table. Okay. And now, if a 44 to 47-year-old mother who had a live birth in 2012 is randomly selected, how many live births would you expect the mother to have had? Expect is the key word there. We're looking for an expected value, and the expected value was already calculated for me, 2.968. I'm going to just copy and paste that over there. 2.968. Round to 1 decimal place. Ooh, rounding to 1 decimal place rounds it to 2.9. Let's see, 9 rounds up to 3. So it's going to be 3 on average. It was the third birth. Just happened to round to a whole number, but that isn't always going to happen. Okay, so you can see this probability calculator really makes easy work of this problem. And you don't have to use StatCrunch. StatCrunch doesn't really have a very handy tool for this. This probability calculator does the trick, I think, a lot easier. All right. That's it for now. Bye.